Okay, so we're gonna go ahead and go over our transformations test corrections. Okay, so it says triangle RST is translated 6 units to the left and 4 units up to create our transformation of RST. What rule best describes this transformation? So left, that means we're going to subtract from x. So, and we're going 6 units. So x minus 6. Up means we're going to add. So this was subtraction, this was add. And y plus 4. So that's going to be D. That's how we do left is subtraction, right's addition to the x, up is plus, down is minus to the x. Okay, pentagon VWXYZ is shown on the coordinate grid. A student reflects the pentagon across the x-axis to create VWXYZ. Which rule describes the transformation? So the key word we're looking for here is x-axis. When you negate something across the x-axis, you're negating your y value. So we're looking for one that says that we're negating our y value. Right here, F. You always negate the opposite value of the axis that you're flipping. So when I flip the x-axis, I negate y. When I flip the y-axis, I negate x. Okay, the coordinate grid shows a pentagon. The pentagon is translated 1 unit to the left, 10 units down. What is a new pentagon? So x minus 1 to go to the left, y minus 10 to go down. Minus 1 minus 10 is A. So for that, those aren't too bad. You're just trying to do up, down, left, right. Got to know where you're adding or subtracting, and if you do addition or subtraction. Triangle ABC was translated 2 units to the right and 3 units down. Right means plus, down means minus. So we have x plus 2. Oops, I don't know why I did that. Y minus 3. X plus 2, y minus 3 is G. Okay. The coordinates of the vertices of the quadrilateral are shown right there. I'm trying to not go too far. Okay, quadrilateral PRST is reflected across the y-axis to create PRST. Which rule describes this? Once again, this time we're reflecting across the y-axis. This time we're going to negate our x values. So B. So pretty much all you need on most of these are just your definitions. What is a definition to make these things happen? Okay. Number 6. The parallelogram PQRS is rotated 90 degrees around the origin to create the parallelogram 9Q PQRS. Which rule describes the transformation? Okay, so the key words here are 90 degrees. So when you go 90 degrees or you go to 70 degrees, you're going to be flipping your x and y values. So first thing we're going to do is we're going to go from x comma y. We're going to go to y comma x. And then we have one more thing. When it's 90 degrees, we negate our x. When it's 270, we're going to negate our y. So our last step is negative x. So this is x negative y. No, they're not reflected. This is negative xy. So they negated the x, but they didn't reflect or reverse them. So it's this one. This one reversed but didn't negate. So there's one step on most of these. This is the only one with the 2 steps. So it's J. Okay, I'm gonna go ahead and do that. Okay, number 7. The figure is rotated 180 degrees clockwise around the origin as a center of rotation to create a new figure. What is a transformation? So 180 is a little bit different. 180 does not flip the order. The order stays the same, but it negates both. So the order stays the same, but it negates both X and Y. So it's A. Okay, quadrilateral PQRS was translated down. I don't know where I got down. Turn 5 units to the right, so that's X plus 5. And 3 units up, Y plus 3. So plus 5 plus 3. G. Number 9, transformation is applied to the figure to create a new figure. What transformation does not preserve congruence? Okay, so congruence means that they're the same. So reflection does not change the size. Translation does not change the size. Dilation does. Rotation does not change the size. Dilation is the only thing that does not change, or dilation is the only thing that changes the size, so it does not preserve congruence. Okay, pentagon ABCDE is rotated 180 degrees clockwise about the origin to form pentagon ABCDE. Which statement is true? Pentagon ABCDE is congruent to pentagon ABCDE, the transformation. The sum of the angles in the pentagon is 180 degrees more than the sum of the other one. Each side length of the pentagon is 2 times the corresponding side length of the pentagon. Each side length of the pentagon is 1/2 the corresponding length. So every single one of these, but F, is talking about the size changing, either by 1/2 times 2, or having more degrees. If it had more degrees, it would have more angles. So this is a rotation. Rotation does not change size. So that means they are going to be congruent, just like our prior problem. It preserves that congruence. So F. Okay, figure PQRS and the new figure are shown on the coordinate below. Which statement does the PQRS was transformed to be the next one? So this could be one of two things based on it. If it shifted, it would keep the same order. So this would be QPSR. So it's not a translation. So now we have to figure out if it reflected across the X, it would go that way. So it reflected across the Y. So that's D. Next one. So I know this one gave some of y'all confusion. Sal translated the circle to the left 7 units, up to the left 6 units, and 7 units up. Which results show that? So I'm going to zoom in a little bit so we can see it better. Okay, you pick any point that you want to start with. I'm going to pick this one right here. When X is 3, and I'm looking for 6 left, 7 up. So we'll do this one at a time. So it starts here. 6 to the left, and we're trying to get to this point here. So 1, 2, 3, 4, 5, 6. That left checks out. Now we got to go 7 units up, 0 to 7. It's that one. If you're not sure, let's go and do another one. The position should stay the same. I went too far. Can't get it to go the amount that I want to go. Okay, see how the dot does not match what we've already checked out? So let's go to the next one. No, I moved over. Oh, because I forgot they're on different pages. So that needs to be close but no cigar. And then no. So the only one that lines up for this one I'm trying to use my keypad on here. I don't like it. Okay. The one that lined up was F. That's the one that went 7 units to the left, or 6 units to the left, and 7 units up. Some of them are close, but that was the only one that worked. Because remember, you're using the same points that you're translating to make sure you moved it correctly. Number 13, pentagon MNPQR is shown on the grid. Pentagon MNPQR is dilated with the origin as the center of dilation using the rule X, Y, 1/4 X, 1/4 Y. So what statement is true? So we're multiplying by 1/4, so it's going to get smaller. So pentagon MNPRQ is larger than the original? No, it's not larger. We're multiplying by a fraction that's under 1, so it's going to become smaller. The pentagon is smaller, okay? The pentagon is smaller and larger. Okay, so we're going to have to figure out why. Because the scale factor is less than 1. Because the scale factor is greater than 1. 1/4 is not greater than 1, so it's B. Okay, I'm going to clear that out. A polygon is graphed on the coordinate grid with X, Y representing the location of a certain point on the polygon. The polygon is transformed using the rule AX, AY. Which statement is true? If A is greater than 1, then the image of the polygon is congruent to the polygon. No. If it's greater than 1, that means we're going to be multiplying it by a bigger number and it's going to get larger. If A is between 0 and 1, the image of the polygon is congruent to the polygon. Once again, no, it's going to make it shrink. So it's not going to become congruent because it's becoming smaller. If A is greater than 1, then the image of the polygon is smaller than the polygon. So no, because if we're multiplying it by a number, if a number A is greater than 1, that means we're making it larger. So there's no reason for it to be smaller. If A is between 0 and 1, then the image of the polygon is smaller. So that means if we're multiplying it by 1/2 or any other that number, we're making the image smaller. So that's correct. So now we got 3 more. Triangle JKL is dilated with the origin with the center of the dilation to create the triangle JKL. Which rule best describes the dilation that had applied to the triangle to create the new triangle? Okay, so really what you need to know is that it's getting bigger. It's getting bigger, so it can't be these are translations. These are the only 2 that we're multiplying by. Because it's getting bigger, it's got to be a number greater than 1. That's less than 1. That's greater than 1, so D. So use those context clues. My transformation has got a little mark on it. This is smaller, so this got bigger, so you have to multiply by a number bigger than 1. Okay, 2 more. Triangle MNP is graphed on the coordinate grid with the vertices at M, -3, -6, and 0, 3, P, 6, -3. Triangle MNP is dilated with a scale factor of U. What is the origin as the center of the dilation to create this? Which ordered pair represents the coordinates of the vertex P? Okay, so we have 6, -3. And because we're dilating it by U, it's going to become 6U, -3U. So J. Dilation means multiplication. So no, no, no. Okay, and last one. Trapezoid PQRS is rotated 180 degrees from the origin. For the trapezoid PQRS, which statement is true? The sum of the angle measures in the trapezoid is 180 degrees less than the sum of the angles of the measures of the new trapezoid. No. Once again, when we do a rotation, the congruent stays the same. Trapezoid PQRS is not congruent. That is not true. They did not change in size, so the congruence is the same. The area of the trapezoid is less than the area of the new trapezoid. If the figures are the same, that means that did not change. And then the angle measures of the trapezoid are equal to the corresponding measures of the other angles. Since they're the same size and did not change size, it's D. They are congruent. Okay, those are all the problems on the test. I'm gonna go ahead and end this. If you have any questions or need me to work out anything, just let me know. Y'all have a great day.